Okay, welcome back, Algebra 1 folks. So we're going to do a real quick review of just one-step equations, solving equations, and how we go about doing this. So our number one rule when we're solving equations is keep that equation balanced. Once it's unbalanced, it shows that you have made a mistake and you've broken the rules and your answer is going to be incorrect. So we always look at our equation as being a balance with the equal sign as acting as our fulcrum. So if I have something like x plus 2 equals 10, that equation sign is my balance. So I typically draw this line here to kind of show me that when I do something to one side, I have to do something to the other side. And so it's just a way to just kind of keep us in check. And so because we're trying to move everything away from that letter, that variable, all it's doing is it's a placeholder for some unknown value. I want to know what's there, and I want to know what's making this work for my situation. And we'll start working with situations and word problems, because math, we practice the ins and outs of solving these equations, but really it's the heart and soul of what happens everywhere in the world. It's our physics, it's our business, and all of that sort of stuff. So if we can do the basic math part, then when we start looking at actual situations where it may apply, we know what to do with it, and it's not as overwhelming. So to be able to undo things to get that variable, and our variable right here is, we want to get that by itself. But on that side, we also have that plus 2. So we have to undo plus 2. And so that's where we get these opposite operations. We also call them inverse operations. And inverse is a special mathematical term that we use to describe that opposite operations. So we've got addition and subtraction. If you have addition, you're going to use subtraction to get rid of it. And remember how we had talked about adding a negative is the same thing as subtraction. So this is where sometimes we like to take this adding a negative and turn it into just a subtraction sign. So that way it's just simpler for our brain to work with those inverse operations and moving things away. Multiplying and dividing. So if you have a multiplication, you're going to divide to get rid of that multiplication. If you multiply by a fraction, multiplying by its reciprocal is a way to undo that. So if my fraction is 3/2, to undo that, I would times by its reciprocal, or the flipped version of it, 2/3. And so we end up getting some canceling here, because 2 divided by 2 gives me 1, 3 divided by 3 gives me 1, and everything's crossed out, so everything's good. And then we'll have a lot more stuff. We'll start working with the power of 2 and the square root, and other things like that that help undo things and help us solve equations, because the more complex you get, the more complex your operations are. So when we start working into electricity and technology, you get more complex operations, so there's more complex inverses. But again, our whole idea is get the variable by itself so we know what that letter is supposed to stand for. So we've got some sample problems over here, and we're going to go ahead and start with the x plus 2 equals -5. So I'm going to draw my line. Oops. I'm going to draw my line to indicate my two sides. And from here, I'm trying to get this x by itself. So on that side, I have the plus 2. To undo that, I would minus 2, because the opposite of adding is subtraction. So this should make itself go away. So now all we have is the x. And on the other side, we're going to simplify that. I've got -5 and I have a -2. Or I can look at it as a -5 and a -2. So 5 negatives and 2 negatives altogether give me 7 negatives. And that's our answer. So on the next one, I have x plus -4 equals -2. So I'm going to draw my line. And again, this is where, what does your brain work with the most? So if I have a plus -4, I could look at it, because it's the same thing as x minus 4 equals -2. And when I look at it that way, I think of, okay, what's the opposite of minus? Well, it's plus. So then I add 4 to both sides, and I can always double check this, because I'm thinking before I draw this line, does this really become 0? And that's what we want. We want this to become 0, so the only thing left is our variable. And then we're going to go ahead and simplify the other side. So I've got 2 negatives, 4 positives. I can also look at it backwards. 4 minus 2 gives me a positive 2. And so these are just little tricks that if you haven't learned it before, may help you with that reasoning. And our next one, I draw my line to indicate my 2 sides. X minus 9 equals negative 11. The opposite of minus is plus, so I'm going to add 9 to both sides. Negative 9 and a positive 9 becomes 0. So that way all I've left is x. A negative 11 plus 9 gives me negative 2. Okay, so our next problem jumps right into the more complicated stuff. So the first thing I have is what in the world is going on right here? I have a 10 right next to an x. And what that indicates is multiplication. I have a positive 10 times x because there's nothing in between it. That indicates multiplication. So to undo multiplication, I would have to divide. So I draw my line, my fraction bar, because fractions are really just showing that I'm dividing. So I'm going to divide by 10 on both sides. So that gets rid of my 10. So x is 5 over 10. Well, we've worked with fractions before. We may not like it, but we've worked with fractions before. So at this point, we have 2 options. We can actually simplify the fraction. And I can find what can I divide top and bottom by to get my answer. So I could divide both of these by 5. And 5 divided by 5 is 1. 10 divided by 5 is 2. I get an answer of 1/2. Or I could actually pull out my handy dandy calculator or cell phone with a calculator, and I do the top divided by the bottom. So if I typed in my calculator 5 divided by 10, I would get a 0.5, which is the decimal equivalent of 1/2. Both are absolutely correct answers. What you want to stay away from is a decimal that goes on forever and rounding your decimal. So if you get a decimal that goes on forever, like 0.23457, you can do a little ... to indicate that it keeps on going, but I'm too lazy to write out the rest. But always try and make sure that you have enough decimals there to illustrate that there's something going on there and it's not much of a pattern. If you have something that repeats, like 0.333333, you can do 0.3, and then we draw the repeater bar over it to show that that 3 just keeps on going forever and we're just too lazy to write it out. And you will find that not all your answers will end up pretty. You'll end up with fractions, you'll end up with decimals, and that's okay. So now we're going to look at our next one. So again, we've got this side-by-side issue. This is not an x minus 3. This is not a negative 3 plus x. The negative 3 is right next to the x. There's nothing between that 3 and x. So that means it's multiplication. So this is a negative 3 times x. To undo times, I divide by negative 3. So the 3's cancel, my negatives are canceling out, and I have just an x here. Now 5 divided by negative 3, I can turn that into a decimal, but as a fraction, there's nothing I can do to reduce that. So me being kind of lazy on that, I'm going to go ahead and leave this a 5 over negative 3. Now something else I want to talk about is it doesn't matter where your negative is. This is really the same thing as negative 5 over 3. The negative belongs to the fraction, not the number on top, not the number on bottom. It's where you feel most comfortable putting your negative, because really it's all one number. And so I like having my negative on top because, in other words, if I put it on the bottom, I tend to forget about it. So that's just what I do. Okay, so going back to our problems, we have 3 halves here. And remember, this 3 halves is right next to that x, so it's being multiplied. 3 halves times x equals 5 over 6. And so with our fractions, we can multiply by the reciprocal. So I multiply by the flipped version. So if this is 3 over 2, I times by 2 over 3. That allows these 2's to cancel out because 2 divided by 2 is 1. 3's cancel out. 3 divided by 3 is 1. So really now all I have is this 1 times x, which is the same thing as x. Now on this side, we've got 2 fractions being multiplied. When we multiply fractions, we're really timesing across the top, timesing across the bottom. So 5 times 2 gives me 10. 6 times 3 gives me 18. And then we could reduce from there. Now some people take this 5 over 6 times 2 over 3, and they simplify first. And so what they're really doing is saying, okay, I'm going to take this top number, and I'm going to divide by 2. So I'm going to divide this by 2, and that's going to give me 1. Well, if I do that on the top, I also have to do that on the bottom, because I got to keep my fraction equivalent. So I'm going to divide this by 2, and I'm going to get 3. And then they multiply. So that way it's easier to go ahead and make some of those simplifications before you multiply. So this way I get 5 on top, because 5 times 1 gives me 5. 3 times 3 gives me 9. And that would be the same answer if I were to divide by 2 here. Or you could go ahead, that's supposed to be a 5, by the way. Sometimes my pen gets a little carried away. And you could also do the 10 divided by 18 on your calculator. Or you could do a 5 divided by 9 on your calculator. It'll give you the same answer. And so I believe this is 0.555, something like that. Or maybe 0.444. I'd have to actually grab a calculator, and normally I don't carry a calculator around with me. So give me 1 second as I pull out my cell phone, because I usually have that on me. So 5 divided by 9. 0.5555. Okay, so moving to the next one, we have 3/4 times x equals 7. So we do the same process as before. 4 over 3, I multiply by that reciprocal. But now I have a whole number times that fraction. So the easiest way of doing this is treat it like our last problem. Turn 7 into a fraction by putting it over 1. So then we're getting our 3's cancel, our 4's cancel, and I do that just to make sure I did everything right. It's kind of my double check. And I times across the top, I times across the bottom, and again, you can leave your answer as a fraction, or you can turn it into a decimal. I tend to leave it as a fraction. Now something else that I haven't been doing that I highly recommend, because if anyone's looking for your work, they're going to want to see your answer. And so I usually do this whole kind of, I block it off so it makes it, and I shade in 2 sides, make it kind of look 3D. So it's easy to find your answer. And then what happens is if your answer is incorrect, we go back and we figure out, what did you do wrong? Did you just accidentally multiply wrong? Or did you accidentally subtract wrong? Or did you actually do your steps incorrectly? And so a lot of us math teachers will go back and look at that, and that's how we grade. Oh, they just accidentally multiplied wrong 1 point. Ooh, they don't even know what they were doing. They were multiplying when they should have been adding, or they were subtracting when they should have been dividing, and then we take off more points. So without that work, we can't really figure out where you may have gone wrong, and we'll take points off. And if you show no work at all, even if your answer's right, we're taking off most of your points, because who knows if your sneaky little eyes looked off of someone else's paper, because that's not going to help you get anywhere in life. Okay, our next one is x over 7. Now this is really an x divided by, that fraction bar is really just a division. So when we're looking at this, we're thinking, okay, what's the opposite of division? Multiplication. So we're going to times by that 7, because the opposite of dividing by 7 would be times by 7. And I times by 7 on this side. And yes, I write weird 7, so it's from my geometry background. So I cancel those out, because 7 divided by 7 gives me 1. So now all I have left is the 1x, which is the same thing as x, and then 21 times 7. And so this will give me 147. And then, of course, always a good idea, box it off. And that's our one-step solving equation. So just to refresh your memory, so that way when we start working into our future stuff, you've got this down, you've got this fresh in your head.